By watching this short video, you're going to learn what an exception is, how exceptions are handled, and why they occur. An exception is something that we weren't expecting. It's an exceptional case. That's where it gets its name. It's an exceptional occurrence. Basically, an exception is this. In case of emergency, break glass. So what happens in our code emergencies? How do we handle them? That's what the exceptions are all about. Going back to the code that we were working with in the debugger example, let's go through this little function. It's a very simple one. It takes in two parameters that are double. The first number is the first number to add. The second number is the second number to add, and it returns the sum of the two numbers. But it's going to throw an exception, an unexpected value exception, if the add-ins are not numeric, because how can we do math on something when you don't give us a number? So let's see how this could occur. We enter the function here, and we have the first number and the second number. Okay. So the first number is filter var to make sure it's a valid float. The second number is also filter var to be a valid float. So far, so good. Now, if one of the numbers is not valid, in other words, filter var would return false here. If one of them is not valid, then we are going to throw the exception. Now, that's our signal to, well, break glass. That's where we have to just stop everything. One important thing about the exception is that once an exception is thrown, everything following the rest of the function is now dead. It's gone. It will not execute. And we'll demonstrate that later in this video. Now, if the exception is not thrown, we will proceed. And we will proceed to add and then return the sum. All right. So we have our function ready to go. Let's test it out for some valid and invalid cases and see how it behaves. So the first thing we have to do when we're dealing with code that may throw an exception, emphasis on might or may, it's not guaranteed to throw an exception. Are we guaranteed to fail every time? Well, I hope not. But it might fail. So we have to try it out. So the first block we put is called a try block. Now the try block that may fail. Well, hopefully not. Now the next thing we do is catch. Now catch is basically code that executes when the exception has occurred and we did have to break glass. So that's the organization of the try catch block. The try block is code that might fail. Hopefully it doesn't. And the catch block is stuff that, all right, we did fail. Now what do we do about it? We got ourselves into this mess. How do we get out of this mess? All right, so let's talk about what we can do when we break glass. For now, let's just go ahead and put up a little error message for whenever we have an exception. Now, one neat feature about exceptions is that they're not just silly error messages. They're more than that. They're way more than that. A good look at the PHP documentation on what an exception can do is actually worth reading, and I'll post that as a link on the page that accompanies this screencast. But a real fast look through it is that not only we have the message, the error message, in this case it would be what I just put here, add-ins are not numeric, but also the file it occurred at. And what that is what was the file name, the exact path of the one that failed, exceptions.php. And then the line number, where did this occur? Where am I? I'm at line 28. That way you can see exactly where things that occurred, and also the get previous. So you can actually do what's known as exception chaining. Exception chaining is basically, we had an exception which came over here and caused another exception, and then that came over there and it caused another exception, and so we have this like chain of exceptions, like 4 related exceptions, a chain of 4 exceptions. And if you're on the 4th one of the chain, you can also say, well, I blame the 3rd one. And then the 3rd one would say, I blame the 2nd one. Then the 2nd one would say, I blame the 1st one. And then the 1st one's like, I'm in trouble. Anyway, these exception chains are actually very, very useful, because what it does is it provides a unambiguous, easy to follow map through your code, through your program. As you get hundreds and then thousands and then tens of thousands of lines, it becomes very useful in the sense that you can go across files, you can go across methods, classes, go across the entire program and say exactly where it failed, and not have to like be scratching your head like where did it fail again? No, the exception will tell you that. That's the power of exceptions, and that's why we are going to be trying and catching so many exceptions. In PHP, I typically see exception chains to be about 3 deep, but I also come from the Java world, and in the Java world I've seen them like 18 to 25 deep, where we have 25 in a chain. And even though 25 sounds daunting, it actually provides a lot of insightful data for when you have a bug. It'll tell you exactly how it happened, and it's really useful. Okay. For now, like I said, we are just going to print out a very simple message saying, hey, an exception occurred. Now the exception has occurred, let's go ahead and try some code that may or may not fail. First one I'm going to try is what I call the happy case, which is just simply the most straightforward, easiest thing. Now, I'm putting 1.2 and 2.3 as numbers here. This should not fail. This should actually work out. Let's go have a look at the page and see if we're right. Look at that. 1 plus 2 plus 2 plus 3 is 3.5. Works perfectly. All right. So let's try another approach to the same problem. Now look what I'm doing. I'm actually putting the 1.2 and the 2.3 in quotes. This effectively makes it a string instead of a double like we put in before. But the question is, will filter var take this stringy 1.2 as a double, or will it throw an exception saying this is not a double, go away? Drum roll, please. It worked. Yes. So yeah, filter var did see strings, but since the strings contained numeric-like data, filter var was like, it's fine, and I'll make it a double for you. You can go on your way. So we still haven't failed yet, but that's good to know. And an important part about filter var. Filter var will take stuff that looks like a string and make it to a double when you use filter validate float. This is a very, very important part. That in the web, a lot of times you'll just get a flood of data all as a string, and filter var is smart enough to kind of dig through those strings and say, hey, this is really a float. Let's make it floaty. Okay, let's try this again now. Now I think we're in trouble because I'm trying to add 2 strings. Can you add 2 strings? No, you can't add 2 strings. I expect this really to fail. So let's try it. An exception occurred. Okay. Yes, an exception did occur. And let's do one more. Let's do 3.4 plus 4.5 and see what result we get. This is going to be another happy case, so I'll just put everything directly in numerically. Let's go ahead and reload the page and see what happens. Nothing. I don't get it. Let's bring up the debugger and see why this did not come up. So I'm going to go ahead and set up debugging. Setting up the debugger is covered in another screencast. And I'm going to put a breakpoint right here. I'm going to put a breakpoint at the second happy case. So now that my debugger is ready, I'll reload the page. And I'm going to go ahead and step in to the function. And this is the one where I put 1.2 and 2.3 as strings here. So first number and second number come in as strings at first, and then filter var converts them into doubles. Now, since they were converted to doubles, this exception does not throw, so we skip this if block. Then we get a sum of 3.5, that's good, and we return the sum. Okay, time for the second function call. Here we're at trying to add two numbers, foo and bar. So we go in, and filter var will convert foo to false and bar to false. Note this, filter var, of course, when it can't do something, it'll actually set the variable to false. So our strings have been converted to false, and since they're now false, we will throw the exception. So notice when I step again, I'm going to step to the throw line. I'm not going to, this part of the code right here does not execute. And so once I've thrown, watch what happens. I actually get to the catch. So if you notice this, we stop here. This is our stop. So since we're stopping here, that's the reason why this line of code right here that we just wrote didn't appear, because it's below our stop. And so this line of code has died out. Because notice, where did the exception handling, where did it put us? It put us right here on the blue line. And it says that the exception occurred. So that solves the reason why we didn't see the 3.4 plus 4.5 that we set up. And that's why we don't see it here. Anyway, the important thing to remember about exceptions is twofold. Number one, exception handling creates very nonlinear flow to your code. You can't read line 1, line 2, line 3, and line 4 and expect them all to execute. The try-catch block will set up a nonlinear progression, and sometimes you go from line 1 to line 2 to line 3 to line 17. Number two, exception handling also, behind the scenes, no effort required on your part, does careful bookkeeping about where and when things happened. So if you're trying to trace through bugs, you're trying to figure out exactly what happened and why, exceptions are extremely useful in revealing how the bug occurred. And digging through exceptions in the debugger is very useful. So be sure and fully take advantage of all the information left behind in the exception chain when you get a chain of exceptions.